Okay, here's a little bit of theory and a few worked examples on volume and capacity of cylinders. Now, first up, we need to really make a distinction between volume and capacity. Volume's a space inside an object. Okay, it's a total amount of space, normally measured in cubic meters or cubic centimeters. Basically, it's how much air can fit inside something. The capacity, though, measures the maximum amount the object can hold. Like if you filled it up with water or sand or anything like that, that's what we mean by the capacity. What's its effective capacity, how much material it can hold. For fluids, we measure in milliliters and liters, and for solids like gravel, sand, that sort of thing, cubic centimeters, cubic meters. Like say for concrete, it's always capacities in cubic meters. Right, there's some relationships that we need to remember. A cubic centimeter is equivalent to 1 milliliter, and 1 cubic meter, or a meter by meter by meter in a cube, is the equivalent of a kiloliter or 1,000 litres. Now, when we're calculating the volume of cylinders, we'll remember that we've done before that the volume of any shape is the area of its cross-section times its height. So for a cylinder, the cross-section's a circle, so we've got pi r squared, so we can put the pi r squared into the formula and then multiply it by the h, so we've got pi r squared h for our cylinder volume. So, some examples. First one, find the volume of the cylinder, correct to 2 decimal places. Fairly standard sort of question. Identify that the radius is 2 centimeters from the center to the outside. The height is 6 centimeters. Write your volume formula down. Write your variables down that you know. Substitute your variables into the equation and calculate your answer. Make sure that you round off to 2 decimal places because that's what the question's asked you to do. Next one, we've got a part of a cylinder. What you can see here, on the end you've got a sector of a circle, and basically it's a cylindrical portion. So the first thing we need to do is we need to work out the fraction of the circle that we've got, because that will be the fraction of the cylinder that we've got. So in a full revolution, we've got 360 degrees. Our cylinder, or a part of our cylinder, is 120 degrees, so our fraction is 120 over 360, or 1/3, which means to calculate the volume, we just do 1/3 times the volume of the whole cylinder. Our radius is 25 from the center point out to the outside, and the height is our 40. Substitute that in. 1/3 times pi times 25 squared times 40. Calculate your answer, and then round it to your 2 decimal places. Okay, third example. In this case, we're going to mix in some capacity. We want to work out the capacity in both milliliters and litres, correct to 1 decimal place of our cylindrical drink can. Now, there's a couple of little hooks here. The first one is we've got a diameter of 60 millimeters, which is the distance all the way across. And we know when we're working out volumes of cylinders, we need the radius, so we need to halve that to get 30 millimeters. The other issue, we want our answers in capacity, which are milliliters and liters, and our link there is a cubic centimeter is equivalent to 1 milliliter. So it's much easier to convert our measurements to centimeters before we start calculating. So from there, exactly the same process as before. Volume of a cylinder, pi r squared h, 30 millimeters for the radius, or 3 centimeters, 125 millimeters for the height, 12.5 centimeters. Substitute those values in, calculate your answer, and that's the value in cubic centimeters. Now we need to convert it into capacity. Remember, a cubic centimeter is 1 milliliter, so your answer in cubic centimeters will give you the number of milliliters, and rounding it off to 1 decimal place, we get 353.4 milliliters. Sorry. Next, we have to convert to liters, and we need to remember our conversions. 1 liter contains 1,000 milliliters, because remember, milli means 1,000th, so there's 1,000 milliliters makes 1 liter. You might remember your conversion charts. Liters times 1,000, we get milliliters, or working backwards, milliliters divided by 1,000 gives us litres, and that's the conversion factor we're going to use. So to work out the capacity in litres, take our measurement in millilitres, divide it by 1,000, get your 0.3534, and the question says 1 decimal place, so rounding that to 1 decimal place gives us a capacity of 0.4 litres. Okay, hope that was helpful.